Okay, so for today's lesson, I'm going to talk about inverse functions, and this is in section 1.5. We need this because in the next part of the trig discussion, we need to talk about inverse trig functions. So inverse trig functions, the notation in this case, the general notation, the original for a function is to say f. Okay, the inverse of the function is just going to be f, and then there's a negative one on top as a power. Okay, do not mistake this as a power though, because f of inverse is not the same thing as 1 over f. Okay, make sure you take note of that. Do not make that mistake. It's very common, but do not just flip it. Okay, there's a process to solving this, so you make sure you follow it. Okay, so the next discussion thing is, what does the inverse of a function mean? Okay, so first thing here, we're switching x and y. Okay, well, my x of my original function becomes the y of my function, for my other function, my inverse function. And then my y of my original function becomes my x of my inverse function. Okay, so here's a quick example. Okay, if f of x is my x and my y, if I have 1a, 2b, and 3c, in that case is my numbers are my x, and my y's are my alphabet a, b, and c. Okay, the inverse then in that case would be my x here is going to be my a, b, and c, and then my y is going to be 1, 2, and 3. Okay, so as you can see, my x and y, they switch. Okay? So in that case, what does this actually mean for this idea? Okay? So that means my function, original function, f of x's domain is now going to be the range of my inverse function, f of x. Okay? Now, that means my range of my function, f of x, is now going to become the domain of my inverse function. Okay? So a quick example. So something we talked about in the past, and they are indeed inverses of each other, and the function that we're using, e to the x. Okay? That means if e to the x, the inverse of that function, as we've discussed, exponential and logarithms. Therefore, my logarithms are going to be my inverse of my e to the x, my exponential function. Okay? Let's go ahead and demonstrate this. Okay, so for f of x, the domain of, well, let's look at the graph. Okay, e to the x looks like this. This is y equals e to the x. And my ln of x looks like that. Okay, so if you look at this diagram here, my domain of y equals e to the x is going to be all real numbers. Okay, so that means my range here is also going to be all real numbers. Okay. Now, the next thing is the range. Okay? Sometimes, in most cases, we don't know what the graph looks like. So the other reason why we want to use inverse functions is to find the domain and range and of the functions that we're looking at. Okay? So in that case, let's just say we assume we don't have this graph, but we do know what ln of x looks like. Okay? The domain of ln of x is all the numbers where x is greater than or equal to 0. Okay? No, not equal to 0. Just greater than 0. That means my range of my function f of x, e to the x, is going to be y is greater than 0. Okay? Remember, domain is my x, range is my y. So make sure when you switch them, make sure you switch your x and your y's as well. Okay? So domain is, everything in here must be in x's, and for range, everything must be y's. So that's the same thing. Okay? Just make sure you notice that domain and range, and then they switch around. Okay? Now, next thing, conditions for existence of an inverse function. Okay? For a function to be invertible, there's two conditions. The first thing here is that the function must be 1 to 1. Okay? What does that mean? That means for every x value, for every y value, there's a value of x. Okay? There is only one value of x. That means if my graph looks like this, it wouldn't work because for one y values, there's two values for x, and that doesn't make sense. You can't do that. You can't invert the function like that. Therefore, to test this idea, we have to use the horizontal line test. Okay, as the name suggests, you just have to get a straight edge and then go vertically upwards and downwards. Okay, so if it touches 2 points for a single value of y, that means the function is not invertible, unless you do a restriction on the domain. We'll talk about that in a little bit. Okay, so let's look at this one. So this function here, as you may have noticed, this is y equals e to the x. Okay, so as we recall, the inverse of e to the x is just going to be ln of x. Okay, let me get a marker. ln of x looks like that. Okay? Now, this next function here, we have y is equal to x cubed. Okay, so this one passes. This one is okay. Okay? Next function is y equals x cubed. Okay, if you go like this, it works. Okay, so it passes a horizontal line test, therefore it is invertible. Okay, so I'm going to show you right now the inverse of this function is just going to be, it will just look like that. This is y is equal to the cube root of x. Okay, let me write that. The cube root of x. So that means this one also passes, so it's okay. Okay. Now the next function here is the quadratic function. Okay, so y is equal to x squared. As you have already looked at earlier, it doesn't pass the horizontal line test. However, because if we restrict the domain, we will end up with a graph that looks something like, it's the right color, like that. And might be asking me, like, what happens if this side? Okay, we'll talk about that in a little bit. So this one doesn't pass. No. Okay. Okay. Now, next part. Example number 4 is the function looks at. That is my tan function. Okay. Tan of x. Okay. The arctan of something we'll talk about later. The graph, this one looks like this, so this one's okay. Okay, so in that case, I'm just saying cross this out, say no. Okay, now, in this one, we have cotangent. Okay, so that means, also, we can also flip this, and my graph looks something along the lines of something like that. Okay? Yeah, these are just a rough sketch. Okay, so we'll talk a little about this a little later. Okay? Now, the next thing, an observation we can also make by looking at this graph is that they are always symmetric somehow. Okay? So if you look at for this one, y equals e to the x and ln of x. Okay? Let me write that ln of x. If you see this, there's a reflection here. And there's a reflection here for example 2. And then somewhat of a reflection for number 3. And in example 4, there's a reflection. And in example 5, there's another reflection. So as you can see, there's a reflection. So the common thing that they have is that f and inverse of f are symmetric, and it's symmetric across the function y equals x. Okay, y equals x is going to look something like, let me use this, something like this. So as you can see, they're all past this one. Like this one's a little messed up, but you get what I mean. Okay, so y equals x is the reflection, the line that the function f and inverse of f reflects off, okay, to get the other graph. Now, the next concept we're going to talk about is how do we find an inverse, okay? There are 3 main steps. The first step here is switch your x and your y, okay, for your function f of x, and then step number 2, solve for y. That means get y by itself, okay? If it is not possible, if you cannot get y by itself, that means either it's not invertible, or you have to restrict the domain. Okay, restriction of the domain we'll talk in a little bit, but let's just go through the main concept. And step number 3 here is something called composition of functions. Okay, composition of functions. Okay, for this one you have to be. We'll talk a little more about this. So let's demonstrate the idea first. Okay, so I'm going to go through a couple examples and then work through it. Okay, so example number 1, y equals e to the x. That's my f of x function. Okay, the same thing as what we did over here. Okay, so that means I switch my x and my y, so my x and my y, they switch. I'm looking to get y by itself. Okay, so how do I do the e on this side? Okay, you have to natural log it, something we did in unit 3. So when you ln both sides, the ln and e will cancel each other out because they are inverses of each other. So you end up with ln of x equals y. Okay, so the y that you end up with, this is going to be your inverse function. So I want you to probably also write inverse of f is equal to y equals ln of x. Okay, so there you go. My e to the x is my original function. Ln of x is my inverse of e to the x. Okay. Again, it's the same idea, the domain and range stuff. Okay, we already did it here, so I'm just going to say crisscross and then leave it at that. Okay, we're going to go through another example of this demonstration in a little bit, and we'll talk about step number 3 where you have to do the composition of functions. And that idea here is just to verify your functions to see if they are indeed inverse of each other. Okay, see you in the next video.